Hello everyone, myself Pavitra Shanbag, Department of Mathematics, AJIET, Mangaluru. In previous two classes, we have discussed about partial differential equation, formation of partial differential equation by eliminating the arbitrary constants and arbitrary function, right? Now, we have done with the up to partial formation of PD by eliminating arbitrary function. There are two varieties we have done, right? One is we have to remove first one function, next we have removed two functions, and we have formed the PDE in previous class, right? Now another form of formation of PDE, that is formation of PDE from phi of uv equal to 0, right? Where u and v are functions of x, y, z. See, this is the standard form, phi of uv equal to 0. This is the standard form, okay? But here you should note very important concept, that is z equal to z of xy. What is the meaning of this? Here in whole module, we should not consider z as a constant. We should consider z as a function of x and y. This is very important step. Dou z by dou x is small p, dou z by dou y is small q. Okay, now first consider phi of uv equal to 0. First you have to remove phi. How to remove phi? Look into this part. First we have to differentiate the given relation partially with respect to x by using chain rule. That is, phi is function of u is function of x. Like that we have to choose. So dou phi by dou u by dou x, plus dou phi by dou u by dou x, because u v are function of x, y here. So what? Dou phi by dou u by dou x, plus dou phi by dou v by dou x equal to 0. Or dou phi by dou u into dou u by dou x equal to minus dou phi by dou v into dou v by dou x. Call it as equation 2. Now, differentiate again the same relation partially with respect to y by using the chain rule. So, what we will get? Dou phi by dou u by dou y, right? Because phi is function of uv are function of y. So, dou phi by dou u by dou y, plus dou phi by dou v by dou y equal to 0. Or dou phi by dou u into dou u by dou y equal to minus dou phi by dou v into dou v by dou y. Our intention is to remove this phi, right? Look into the equation 2 and equation 3 and just divide. Then dou phi by dou u cancels. What remains? Dou u by dou x by dou u by dou y remains. Here minus cancels. Dou phi by dou v cancels. What remains? Dou v by dou x by dou v by dou y. So what is our required PDE? So if you differentiate this, divide by equation 2 by 3, you will get dou u by dou x by dou u by dou y, or ux by uy suffix, right? U suffix x and u suffix y equal to v suffix x by v suffix y. So this itself is the required PD, right? Now let us discuss one problem under this. Problems based on this is very important. First example, form the PDE by eliminating the arbitrary function from the following. That is, phi of xy plus z square comma x plus y plus z equal to 0. First you have to write the procedure, that is, we have phi of uv equal to 0. Then what we have to do? Differentiate the given relation partially with respect to x by using chain rule. So you will get dou phi by dou u by dou x equal to minus dou phi by dou v by dou x, right? This one we have already discussed in the previous slide. Similarly, differentiate the given relation partially with respect to y. You will get dou phi by dou u into dou u by dou y equal to minus dou phi by dou v into dou v by dou y. Now dividing this, you will get ux by uy equal to vx by vy. So this itself is required PDE. But what is u and what is v, that you have to write here. See, look into the given problem. Phi of u comma v, you have to compare. What is u? Xy plus z square. What is v? X plus y plus z. First you compare with that one. So here u equal to what? Xy plus z square, and v equal to x plus y plus z. I want here we want what? Ux by uy and vx by vy. That is nothing but differentiate u partially with respect to x. Similarly, differentiate u partially with respect to y. Similarly, differentiate with v with respect to x partially. Differentiate v partially with respect to y. Check what you will get. What is dou u by dou x? Differentiate this with respect to x. So here y. plus 2z into dou z by dou x, right? That is p. So what? Y plus 2zp. Similarly, if you differentiate the same partially with respect to y, what you will get? Dou u by dou y, that is nothing but here with respect to y means x constant, x as it is, plus 2z into dou z by dou y, that is q, right? So what is v here? X plus y plus z. Partial derivative of v with respect to x is 1 plus 0 plus dou z by dou x, that is p. So 1 plus p. Similarly, v with respect to y partially means 0 plus 1 plus dou z by dou y, that is 1 plus q, right? So just apply the formula dou u by dou x by dou u by dou y, that is y plus 2zp divided by x plus 2zq equal to what? 1 plus p by 1 plus u. Now cross multiply and collect p term one side, then q term, then remaining in the RHS. So you will get x minus 2zp plus 2z minus y into q equal to y minus x. So this is required PDE. Okay. Now next move to the another slide. Say phi of x plus y plus z comma x square plus y square minus z square equal to 0. First you have to compare it with the phi of u v equal to 0 and you have to repeat the process. That is, what is the procedure given here? First we have to compare phi of u v equal to 0, differentiate the same partially with respect to x and with respect to y by using chain rule. Then you will get ux by uy by vx equal to vx by vy. That relation you have to mention in each and every sum. Okay, that procedure carries 3 marks, a very important procedure. Previous 2 slides we have explained the same. Now here just find what is u and v. Just compare phi of u comma v equal to 0. What is u? X plus y plus z. What is v? X square plus y square minus z square. Okay, now find dou u by dou x and dou u by dou y. What is dou u by dou x? 1 plus 0 plus dou z by dou x. This is very important because z is a function of x and y. We have mentioned in the beginning only. Throughout the module you should remember that dou z by dou x is small p. Okay, so ux is 1 plus p. Similarly, what is uy? 0 plus 1 plus dou z by dou y, because z is function of y also. So that is q. 1 plus q. Similarly, how to write vx? 2x plus 0 minus 2z dou z by dou x, that is minus 2zp. 2 common, x minus zp. Similarly, what is vy? 0 plus 2y minus 2z dou z by dou y, that is minus 2zq. So 2 common, y minus zq. Now just divide ux by uy equal to vx by vy. So 2 to get cancel. What remains? 1 plus p by 1 plus q equal to 2 to get cancel. X minus zp divided by y minus zq. Cross multiply 1 plus p into y minus zq equal to x minus zp into 1 plus q. And collect p term first, then q term, then remaining. So y plus z into p minus x plus z into q equal to x minus y. So this is required partial differential equation, right? Now let us move to another example. See here, phi of x square plus 2yz comma y square plus 2zx equal to 0. Again compare it with phi of u comma v equal to 0. Write what is u, what is v. U is here x square plus 2yz, v is here y square plus 2zx, and just explain the procedure. For procedure 3 marks is there, that is already explained in previous 2 slides. Same thing you have to explain here. Now differentiate this partially with respect to x and y. So what is ux, what is uy right here, what is vx, what is vy right here. What is ux here? Differentiation of x square is 2x plus, here with respect to x means 2y into dou z by dou x, that is p. So 2x plus 2yp. Similarly, what is uy? Here 0 plus here 2 constant, keep outside. Product of these two, because y into dou z by dou y plus z into 1, that is y into q plus z into 1. Okay. Similarly, what is vx? Here 0, but here there are product of two terms and z is also function of x. You should remember that. So 2 keep outside, z into 1 plus x into dou z by dou x, that is p. So x into p. Similarly, what is vy? 2y plus here 2x constant, 2x as it is, z y, that is q, right? 2y plus 2xq. Now ux by uy equal to vx by vy. This is PDE. So what we will get? 2 to get cancel everywhere because it is common. X plus yp divided by yq plus z equal to z plus xp divided by y plus xq. Now cross multiply and simplify. Here one term get cancelled, that is ypxq. Here also ypxq. See here, that term cancel, and remaining term you have to express in the form of coefficient of p then plus coefficient of q into remaining equal to remaining all you have to write, that is y square minus zxp plus x square minus yzq equal to z square minus xy, which is required PDE, right? Now similarly work out with the remaining sums from this formation of PDE by eliminating arbitrary function. Here formation of PDE by eliminating arbitrary function, there are total 3 varieties we have done with that. Okay, now next let us move to the solution of non-homogeneous PDE by direct integration. Now here the PDE which can be solved by direct integration in the place of usual constant of integration. Okay, we must however use arbitrary functions of the variables held are fixed. After explaining you will come to know this. See, our intention is to find just this z, that's it. Okay, now what is given here? Dou square z by dou x square equal to x plus y given. Now see here, dou square z by dou x square, that means partial derivative of the z with respect to x twice given. That means we have to integrate with respect to x twice. Then only we can obtain the value of z. Now first integrate z with respect to x. So what you will get? One partial derivative cancel. Remaining term is dou z by dou x. Now if you integrating with respect to x, then x integration is x square by 2 plus y is constant, integration of 1 remains here. Integration of 1 means x. So yx plus we are adding some constant of integration, right? That is, instead of, say, if we integrate with respect to x, constant in terms of y, that is f of y. Understood? Once again I will explain. Say here we want z. For that we have to remove this dou square by dou x square. To remove derivative we have to apply integration because it is the reverse process. Now if you integrate once, you will get dou z by dou x here. That is integration of x is x dx, that is x square by 2. Integration of y dx, y constant, 1 dx remains, that is x. Plus we are adding c, right, constant of integration. Instead of c we have to use f of y. Why? We are integrating with respect to x means f of y. Suppose here y is there, then f of x, like that. Okay, now again what remains? Dou z by dou x remains. So what we need to do? Once again we have to integrate with respect to x, so that z part only remain. Again integrate with respect to x, z equal to integration of x square is x cube by 3, right? X cube by 3 into 2 here denominator, so 3 into 2 is 6. Again integration of yx dx, so y constant keep as it is, y outside. Integration of x dx is x square by 2 plus here integration of fy dx, so fy is constant, 1 dx, that means x into fy plus constant of integration, one more required, right? Because we are integrating with respect to x, once again constant in terms of y, that is we are choosing in terms of gy. Okay, so this is required solution of given non-homogeneous PDE. Okay, now next let us move to the next problem. Here second example, dou square z by dou x dou y equal to x by y plus a, right? Now here we have to integrate with respect to x as well as y, because it is in dou square z by dou x dou y means dou by dou x of dou z by dou y, right? Now either integrate with respect to x first or integrate with respect to y first, it is left to you. Now clear one by one. To get z we have to integrate twice because second order derivative is there here. If you integrate twice, you will get z. But first integrate with respect to x here. So dou by dou x of dou z by dou y, right? If you integrate, dou z by dou y only remains. Integration of x is what? X square by 2 and 1 by y is constant. Keep y fixed. See here, 1 by y into x square by 2 plus integration of a dx means a constant, that is integration of 1 dx, that is x, ax, plus constant in terms of what? Y, that is f of y. Now we want z. So what we have to do? Integrate with respect to y. So z equal to what? Here x square by 2 constant keep as it is. 1 by y integration is log y plus ax constant integration of 1 dy, that is y, plus here you should be very careful, integration of small fy dy plus g of x. Okay, now you can write small fy gy as it is, or you can write it in terms of capital Fy. Why we have to use capital Fy? Because if you integrate function in terms of y, you will get some other function in terms of y, that is x square by 2 log y plus axy plus capital Fy plus gx. You can write like that also. Okay, now next let us move to the next problem. Here dou cube z by dou x square dou y plus 18xy square plus sine of 2x minus y equal to 0 given, right? Now here totally third order partial derivative. That means how many times we have to integrate? 3 times. But how many times we have to integrate with respect to x? 2 times, and 1 time with respect to y. Look into here. Dou cube z by dou x square dou y, that is nothing but we have to integrate twice with respect to x and once with respect to y to get z value, right? Now first let us integrate with respect to x once. Then what you will get? Dou square z by dou x dou y, because 1 we are removing here, right? Now with respect to x, y is constant. So here what you will get? Plus 18 y square constant. Integration of x dx is x square by 2. So what you will get? 18 by 2 is 9. 9x square y square, right? Now integration of sine of function means minus cos of function. Minus cos of 2x minus y divided by what? With respect to x, coefficient of x is here 2. So that is 2. Okay, equal to what we have to write? Since we are integrating with respect to x, here we have to add the constant of integration in terms of f of y. Now what we have to do? Again we have to integrate with respect to x. Then what remains? Dou z by dou y remains. Plus with respect to x means 9y square constant, right as it is. Integration of x square is x cube by 3. So what you will get? 9 by 3 means 3. 3x cube y square, right? Now again integrate cos of function. Integration of cos is sine. So minus cos 2x minus y, its integration is minus sine 2x minus y divided by 2 already there, and one more 2 will multiply because coefficient of x is here 2, right? 2 into 2, that is 4. Now integrate this fy with respect to x. So fy is constant. 1 dx remains. Integration of 1 dx means x. Again we have to add the integral constant here. Since we are integrating with respect to x, again we have to add the constant of integration in terms of y, that is g of y. Okay, now last part. What is given here? Dou z by dou y is there, right? Now what we want here? We want z. So to find z, what we have to do? Integrate with respect to y. So dou z by dou y, if you integrate with respect to y, you will get z. Now here plus 3x cube constant, right as it is 3x cube. Integration of y square with respect to y is y cube by 3. So 3 get cancelled, remaining term x cube y cube. Next, integration of sine of function is cos of function, right? Here with respect to y given, so what we will get? Cos of 2x minus y divided by 4 into 1 more minus, because with respect to y means minus 1. But here you should remember one thing, integration of sine means minus cos. Minus into minus plus cos, right? Plus the cos of 2x minus y divided by here 4 into minus 1, that is minus 4. So plus and minus will get minus. Okay, now equal to what? With respect to y we are integrating, write x as it is, integration of small fy dy plus integration of small gy dy. Since we are integrating with respect to y, we have to add the constant of integration in terms of x, that is wx or hx, whatever it may be. Function in terms of x, we have to add the constant. So simplify here, z plus x cube y cube minus cos of 2x minus y by 4 equal to x into, this is integration of small fy dy is capital Fy, integration of small gy dy is capital Gy plus wx. So this is the required solution of given PDE, right? Now let us move to the next example. What is given here? Dou square z by dou x dou y equal to sin x sin y, for which dou z by dou x equal dou z by dou y equal to minus 2 sin y when x equal to 0 and z equal to 0 if y is an odd multiple of pi by 2. Here the procedure is same, we need to find z, but whatever we are getting the constant of integration, right, that we have to find the value by applying these conditions. Okay, now first look into this partial derivative, dou square z by dou x dou y, that means second order partial derivative here. Now we want here z, right? To obtain z, what we have to do? Integrate with respect to x as well as integrate with respect to y. Now first with respect to x, because here they have given a condition for dou z by dou y. So first remove dou by dou x, then you will get dou z by dou y condition directly, right? Now integrate the given relation with respect to x and keep y constant. Then what we will get? Dou z by dou y equal to what? With respect to x means here constant is sin y constant, right? Sin y as it is. Integration of sin x is minus cos x. So dou z by dou y equal to what? Minus cos x into sin y. And which constant we have to add? Integral constant here with respect to x means f of y is constant of integration, that we have to add. Okay. Now after writing this step, you have to apply the condition. What is given condition here? Dou z by dou y equal to minus 2 sin y when x equal to 0. Just wherever dou z by dou y, apply minus 2 sin y, and wherever x equal to 0, wherever x, apply x equal to 0. Now look at here, minus 2 sin y equal to what? Minus sin y cos 0. Cos 0 means 1. So minus sin y plus small f of y. Okay. So minus 2 sin y equal to minus sin y plus f of y. If you take minus sin y this side, it will give us what? Plus sin y. So minus 2 sin y plus sin y equal to small f of y. So what is small f of y? Minus sin y. So we got minus sin y directly. Now replace back here. So what you will get? Dou z by dou y equal to minus sin y cos x minus sin y. Okay. Now we want z, right? To find z, what we have to do? Integrate with respect to y and keep x constant. If you integrate with respect to y, what remains? Z. Z equal to, now integrate with respect to y means cos x keep as it is, integration of minus sin y, that is cos y, right? Integration of sin y is minus cos y, but here minus sin y is there, plus cos y. So cos y cos x, again integration of minus sin y means plus cos y, plus here with respect to y we are integrating, so the constant of integration in terms of x, that is g of x. Okay. Now what is the condition given? Second condition, see here, z equal to 0 if y is an odd multiple of pi by 2. So when z equal to 0, what happens? If z is 0 and y is odd multiple means what? 2n plus 1 into pi by 2. Now just substitute here, you will get what? 0 equal to cos of 2n plus 1 into pi by 2 cos x plus cos of 2n plus 1 into pi by 2 plus g of x. But what is cos of 2n plus 1 into pi by 2? Cos pi by 2 only 0. Again cos of 2n plus 1 into pi by 2 means we will get 0 only. So what we will get? Z equal to 0. Even this term also 0. Even this term also 0. So what is g of x? Obviously 0, right? Because cos of 2n plus 1 into pi by 2 is 0. Therefore even z also 0 given. So therefore gx also 0. So what remains finally? Z equal to cos y cos x plus cos y plus 0. Now what is common here? Cos y common, remaining term cos x plus 1. So this is the final solution of given PDE. Now next problem. Solve dou square z by dou x square equal to xy, for which dou z by dou x equal to log of 1 plus y when x equal to 1 and z equal to 0 when x equal to 0. Now look into this part carefully. Our intention is to find z, that's it. But condition also you have to observe once again. Dou square z by dou x square given. Our intention is to find z, but before that here they have given one condition, dou z by dou x. So better you find dou z by dou x, again then you can find z. Look at here. Here second order partial derivative, that means 2 times differentiate, here derivative given, that means you have to integrate twice with respect to x only, because dou x square given. Now first integrate with respect to x. So what you will get? Dou z by dou x equal to, what is integration of x? X square by 2, right? So x square by 2 into y plus constant of integration is what? F of y. Clear? Now apply the condition. What is given? Already given. Dou z by dou x equal to log of 1 plus y when x equal to 1 given. So apply this condition here. You will get what? Log of 1 plus y equal to y into 1 by 2, because x equal to 1 given, plus f of y or small f of y is nothing but log of 1 plus y minus y by 2, right? Now expression 1 becomes what? Therefore dou z by dou x equal to x square y by 2 plus log of 1 plus y minus y by 2. Now our intention is to obtain z. Integrate with respect to x, you will get z equal to, now y by 2 constant, integration of x square is x cube by 3. So x cube by 3 into 2 means 6 here. So yx cube by 6 plus, here with respect to x means all are constant here. Write constant as it is. 1 dx you have to assume here. That is integration of 1 dx is x. Again since we have integrated here with respect to x, we have to add the constant in terms of y, that is g of y, because f of y we have already used. Now g of y. Now use the second condition. What they given? Z0 when x equal to 0. Apply that condition and find the value of g of y. See z0, x also 0. So what you will get? Z0, x also 0, x also 0 here. So completely g of y equal to 0, because 0 into any quantity is 0 here. Obviously z equal to what? X cube y by 6 plus log of 1 plus y minus y by 2 into x. This condition we have used just to find f of y and g of y, right? Okay, now let's move to the next problem. See, solve the equation dou square z by dou x dou y plus 9x square y square equal to cos of 2x minus y. Given that z equal to 0 when y equal to 0 and dou z by dou y equal to 0 when x equal to 0. Now again here second order partial derivative given, that means we have to integrate partially with respect to x and with respect to y here, right? Now if you integrate partially with integrate with respect to x here, what you will get? Dou by dou x of dou z by dou y, you have to split like this. dou by dou x we will remove, right? If you integrate with respect to y means here with respect to x means this dou by dou x term remains. Remaining term of dou z by dou y plus 9 into y square constant, integration of x square is x cube by 3 equal to integration of cos means sine of 2x minus y divided by 2 because coefficient of x is here 2 divided by 2 plus f of y constant of integration, right? That is dou z by dou y plus 3x cube y square equal to sine of 2x minus y by 2 plus f of y. But what is the condition given? Dou z by dou y equal to 0 when x equal to 0 given. Use that condition and find the value of small f of y. Dou z by dou y 0, x also 0. So 0 plus 0 equal to sine of 0 minus y by 2 plus f of y. So what? Minus sine y by 2 plus f of y equal to 0. Or what is small f of y? Sine of minus theta is minus sine theta. So minus sine y by 2 plus f of y equal to 0 means f of y equal to sine y by 2. Right? So we got f of y equal to sine y by 2. Now to apply the second condition, see here second condition they have given z equal to 0 when y equal to 0. So that means we need z. So first write what is dou z by dou y here. Dou z by dou y plus 3x cube y square equal to sine of 2x minus y by 2 plus f of y is replaced by now sine y by 2. Now our intention is to find z, right? Now to find z we have to integrate with respect to y now, keeping x constant. So what you will get? Z. Integrate with respect to y, then z plus 3x cube constant, integration of y square is y cube by 3. So that this 3 get vanished equal to integration of sine of function means minus cos of function, that is minus cos of 2x minus y divided by 2 already there. Here integrate with respect to y means here coefficient of y you have to multiply in the denominator, that is minus 1. Again here integration of sine y is minus cos y divided by 2 constant. Now with respect to y we are integrating, that time constant of integration is g of x. So plus g of x. Now simplify, 3 cancels, z plus x cube y cube equal to minus into minus here plus cos of 2x minus y divided by 2 minus cos y by 2 plus g of x. Okay. Now use the condition what they given, z equal to 0, x also what z equal to 0 and y equal to 0 given. Now use this condition in the previous step, z is 0, y is 0. So LHS completely vanishes. What remains here? Half cos of 2x minus 0. So cos 2x by 2 minus cos 0 by 2. Cos 0 means what? 1 minus 1 by 2 remains plus g of x. So what we will get? G of x. Therefore, see g of x equal to 1 by 2 minus 1 by 2 cos x, or 1 minus cos 2x by 2. But 1 minus cos 2x is nothing but 2 sin square x. 2 sin square x by 2, 2 to get cancelled, remaining term is sin square x. So finally what you will get z, just replace f of y and g of y in the expression. What you will get? Z plus x cube y cube plus 1 by 2 cos of 2x minus y minus cos y by 2 plus what is g of x? We obtain now sin square x. So this is required PDE. Okay. Now next let us move to the next problem. Now solve the equation dou square, sorry this question again by mistake we have repeated, same question it is, sorry. Okay, this one we have done already, we have done same problem. Okay, dear students, once again you try to work out with all the problems under this